Hello everyone, I'm Sonali. In this part, we will learn binary search. This is the next type of searching. We have learned already linear search or sequential search and variation of sequential search. Now we will see binary search. What is actually the binary search? Why name is binary? Why we are using this binary search? Linear search having a time complexity O of n. Okay, means what? Suppose 1 million elements in array. So here require the 1 millionth comparison. Means suppose in the array, if 10 elements are exist and in worst case we require the 10 comparison to find the element. But in a case of binary search, suppose the 1 millionth of element in the array, then we need only 20 comparisons. How? Let's see in this binary search. Let's see in this topic how to do this, how to search element using binary search algorithm. And time complexity of this binary search algorithm is O of log 2n. Okay, let's see. See here binary search. First requirement for the binary search is we require the sorted array. If our array is not sorted, then first use the sorting algorithm to sort the array. Okay, and after this start using the binary search. Binary means what? Here we are dividing the array into two parts. First interval and second interval. Okay, we are doing repeatedly this procedure. Okay, begin with an interval covering the whole array. Okay, first, okay, how to find, see, first find out the your beginning, then end, and then mid. Okay, here we are finding the mid. Mid means what? Beginning plus end divided by 2. And our key element is suppose the less than mid, then we will search in our left part. And if our search element is greater than mid, then we will search in right part. Okay, depending on this key. Okay, so first match your key value, compare your key value with the mid, and then decide uh, which part in which you are searching. Okay, see here is begin with an interval covering the whole array. If the value of the search key is less than the item in the middle of the interval, narrow the interval to the lower half. Okay, otherwise narrow it to the upper half. Okay, depending on this mid element. Repeatedly check until the value is found or the interval is empty. See, here we are using the procedure. Okay, binary search start by testing the data in the element at the middle of the array. So here is a mid. How to calculate mid? See, begin plus end divided by 2. Okay, if it is in the first half, we do not need to check the second half. Okay, so half time is reduced here. If it is in the second half, we do not need to test in the first half. Okay, we repeat this process, eliminating the half of the remaining list with each test until we find the target or determine that is inside the array or not. Here is one example for this binary search. See, here is a different element 10, 15, 20, 24, 34 and 45. If here we are using sequential search, then at that time necessary to compare first this 34 and 10, then 34 and 15, 34 and 20, then 34 and 24, and 34 and 34. Here we will find the 34 equals to 34. Okay, so number of comparison need is 5. But when we are using the binary search, let's see how many comparisons are required. Here, in binary search, here is your first element, means here is beginning, and here is your last element, this is your end. Okay, first element is 10, last is 45. First element location is 0, last element location is 5. Okay, we are adding this plus this. Okay, so mid beginning equals to, see, a of mid is less than 34. Okay, how to find this mid? Beginning plus end divided by 2. So 5 by 2 is what? 2. So here is our mid. Okay, here is your mid. Then compare this mid with your value, with your key. Okay, 20 and 34. Compare this 20 and 34. This 34 is greater than this mid. Okay, this 34 is greater than your mid. So now find your element, this 34, inside this part, this upper part. Okay, so set again the location of this beginning and end. Okay, beginning is equals to mid plus 1. No need to search for this. So this next element, only we want only this part. So this is your beginning and this is end. Okay, and then again check for this. Again find out the mid. Suppose this is your element. Okay, 3 plus 5 is 8. 8 by 4. Okay, so here find the this is your mid. 34 is your mid now. Okay, beginning plus end divided by 2. So you will get the 34. Then first compare this 34 with your element. If the same, then return the location. If not same, then again based on this result, check in a upper lower half or in a upper half. See here, 34 equals to 34. Okay, so A of mid equals to 34. So we will got this element at the location. We got this element at the location A of 4. So return the location of this. For this we are using the pseudo code. See, this is a pseudo code for our program. List, last, target, location. Okay. List, last, target, location. Okay. List must contain at least one element. Last is the index to the last element in the list. Target is contains the data to be located, and location is address of an index in calling algorithm. See, set beginning to 0, set end to last. Okay. We can use any algorithm. You can use the different variables here. No need to do this exact, but write the steps properly. Okay. Look. Begin is less than equals to end means till this end. Okay, we are starting from this begin. Begin less than equals to end till the end of this part. Search set mid to begin plus end divided by 2. If your target, this is your target, is greater than list of mid, means see, if your this target is greater than mid, greater than this 20, then look in a upper half. Okay, set begin to mid plus 1. So now here begin is our mid plus 1 means the 24. Else, if target less than list of mid, look in a lower half. If your target is less than mid, then look in a lower half. Set end to mid minus 1. See, when you are searching in this part, set mid equals to mid plus 1 means the 24. If your search element is in a lower half, your mid will be mid minus 1. So mid is your end is 15. Okay. When you are trying to find the element in this lower half, this is your mid, then this mid minus 1 is the end for this lower half. Else found force exit. If found element, then the exit from this, then set begin to the end plus 1. End. Here end loop, set the location to mid. If target equals to list of mid, in some cases you will get the target element at the mid only. So at that time return directly the location, set found to true, else set found to false. End if return found element and end of your binary search. Okay, compare this your algorithm with this example, then it will be better. You will got the clear concept of this binary search. You can write the code recursive function, non-recursive function for this. What is mean by recursive and what is mean by non-recursive? Recursive function means function calling itself. Here we are not giving the call to this function. Okay, this is non-recursive function. Int a, int I, int j, and int k. Okay, this is your key. Find the element inside this array. When you are trying to finding in this array, I equals to 0, j is equals to 5 means the last element, and c is your mid. Okay, so into c equals to I plus j divided by 2. 0 plus 5 divided by 2. So 0 plus 5 is 5. 5 divided by 2 is 2. So this is your mid. 20 is mid. While a of c not equals to c, you are finding which element? Suppose you are finding the 34 or the 15. Then first, I is less than equals to j. This condition also and this also I less than j. Then if key greater than a of c, if your key is greater than this mid, then search in this part. I equals to c plus 1. I equals to c plus 1 means here is your C and this is your C plus 1. Now set I to this location. Okay. And if else J equals to C minus 1. Here is your C. This is your C minus 1. And again do the same procedure. C equals to I plus J divided by 2. Again search in this, search the mid. Then again two part and search. In this way perform this procedure till the A of C not equals to C. If I less than equals to j, return c, otherwise return minus 1 if your element is not present inside this array. Here is a comparison between sequential search and binary search. What is sequential search? Here we are searching the element sequentially. Okay. And here in a binary search, we are searching the element either in a upper part or in a lower half. Okay. Sequential search is used to find the key in a randomly arranged array. Here is elements are not in a proper order. But when elements are in a proper order, we are using the binary search. A linear search scans one item at a time without jumping to any item. Okay. Here we are comparing each and every item with our key elements. In a binary search, we are only comparing half of array. Okay, because we are finding the mid, and depending on the mid and key comparison, we will find the element in a lower half or in a upper half. It is slower than binary search because it compares each and every element. So it takes the time. It is a much faster than the linear search. In a sequential search, time complexity is O of n because here we are comparing all the elements. So suppose the 10 elements, 10 comparisons are required. In a binary search, its time complexity is O of log n. Okay, this is O of log 2n, actually log 2n. And in a sequential search, the example we are using the sequential search to search the element in the linked list. We are using this binary search in a sorted array. Okay, here require the time complexity O of log 2n. Thank you.